Since PostgreSQL 10 in 2017, logical replication has had one painful limitation. Sequences do not replicate. Your table data replicates. Every insert, update, delete stream to the subscriber. But the counter that generates the next ID? It stays at 1. You promote a logical replica. Your app inserts a row. Nextval returns 1. But user ID 1 already exists. Duplicate key error. In production. At 3 a.m. Every DBA who has done a major version upgrade with logical replication knows this pain. You write a shell script that queries max ID from every table and calls setval for every sequence. 40 lines. Error prone. You hope you did not miss one. PostgreSQL 19 fixes this with 2 words, all sequences. 20 slides. The problem, the syntax, the live demo, and the exact upgrade workflow. Let us get into it. 6 things in 18 minutes. The problem. The new all sequences syntax. The sequence sync worker. A live hands-on demo. The refresh sequences command. And the gotchas you need to know before upgrading. Stay to slide 16, I will show the exact upgrade workflow that replaces 40 lines of shell with 2 lines of SQL. Here is the problem, straight from the PostgreSQL documentation. Section 29.8, Restrictions. Quote, sequence data is not replicated. End quote. That same sentence has been in the docs since PostgreSQL 10. Through 11, 12, 13, 14, 15, 16, 17, and 18. 9 versions. 7 years. Same restriction. The docs continue, the data in serial or identity columns backed by sequences will of course be replicated as part of the table, but the sequence itself would still show the start value on the subscriber. In practice, this means 3 things. First, on failover, you get duplicate key errors. Second, on upgrade, you need a manual sequence reset script. Third, in multi-node setups, sequence values drift silently between nodes. The rows replicate. The counter does not. Here is what every DBA has been writing since 2017. A bash script that loops through every table, finds the sequence backing each serial or identity column, queries the max value from the table, and calls setval on the subscriber. This script has problems. It misses standalone sequences not tied to any table. It races with concurrent inserts. If someone inserts a row between your max query and your setval, you get a gap or a conflict. And it varies per team. Everyone has their own version. None are fully correct. Now look at the right side. PostgreSQL 19 replacement, create publication my_pub for all tables, all sequences. Then on the subscriber, alter subscription my_sub refresh sequences. 2 lines of SQL. Catches serial, identity, and standalone sequences. No race conditions. No missing sequences. Let me put this in context. PostgreSQL 9.6 in 2016 introduced logical decoding, the foundation. PG 10 in 2017 added logical replication with the pub/sub model. PG 11 added truncate replication. PG 13 added partition table support. PG 15 added row filters and column lists. PG 16 added parallel apply. PG 17 added failover slots. And PG 18 in 2025? Virtual generated columns. Maintain privilege. But sequences still did not replicate. PG 19 finally adds all sequences, sequence sync, and refresh sequences. After 7 years, the restriction is removed from the docs. The syntax is simple. Before PG 19, create publication my_pub for all tables. Tables only. No sequences. PG 19, create publication my_pub for all tables, all sequences. 2 additional words. All your serial sequences, identity sequences, and standalone sequences are now published. You can also publish sequences only for all sequences without tables. Useful if you already have a table publication and want to add sequence sync separately. This was committed by Amit Kapila on October 9, 2025. The primary authors are Vignesh C. and Tomas Vandra. Reviewed by 8 contributors. This was a big, carefully reviewed patch. One important limitation: all sequences cannot be combined with table or tables in schema. It is all or nothing. Granular per sequence publishing is proposed for PG20. Behind the scenes, PG19 adds a new background process, the sequence sync worker. When you create a subscription or call refresh sequences, sequences are flagged in it in PG_subscription_L. A single sequence sync worker launches, fetches the current values and page LSNs from the publisher, updates the local sequences in batches within a single transaction, and marks each one ready. Key point: one worker handles all sequences. It batches them for efficiency. And it is not continuous, it runs at specific trigger points, then exits. This is snapshot sync, not streaming. Sequences sync at subscription creation, at refresh publication, or when you explicitly call refresh sequences. They do not stream on every next val. That would be prohibitively expensive. Sequences sync at exactly 3 moments. 1. Create subscription. When you create the subscription, published sequences are fetched and synced immediately. 2. Alter subscription refresh publication. This picks up new or dropped sequences. It syncs newly added sequences but does not resync existing ones. 3. Alter subscription refresh sequences. This is the new command. It resets all sequences to init and resyncs their values. This is the one you run before failover. Key insight: refresh publication handles schema changes, new or dropped sequences. Refresh sequences handles value drift, resyncs all values. Use both, but at different times. Let us build this live. We create 2 databases, demo_src on port 5432 as the publisher, and demo_dest on port 5433 as the subscriber. On both sides, we create a users table with a serial primary key, an orders table with an identity primary key, and a standalone sequence called invoice_number_seq. 3 sequence types: serial, identity, standalone. PG19 publishes all 3. The schema must exist on both sides before creating the subscription. Logical replication replicates data, not DDL. On the publisher, create publication demo_pub for all tables, all sequences. We verify with \drp, it now shows all tables, true, all sequences, true. That is the new column. On the subscriber, create subscription demo_sub connection host equals 127.0.0.1 port 5432 name demo_src user replicator publication demo_pub. PostgreSQL responds, created replication slot demo_sub on publisher. The subscription creation automatically triggers the sequence sync worker. Sequences in init state are synced to their publisher values right away. On the publisher, we insert 3 users: Alice, Bob, Carol. Users_ID_seek advances to 3. 2 orders. Orders_ID_seek advances to 2. And we call next val on invoice_number_seek 10 times. It advances to 10. Now on the subscriber, we check. The rows are there: Alice, Bob, Carol. Rows replicate as always. But the sequences? Users_ID_seek shows last_value 1. Still at 1. What happened? Sequences synced at subscription creation when there was no data yet. Since then, the publisher advanced all 3 sequences, but those advances were not streamed. The fix: alter subscription demo_sub refresh sequences. 1 command. Now we check again. Users_ID_seek, 3, orders_ID_seek, 2, invoice_number_seek, 10. All 3 types serial, identity, standalone synced correctly. Someone in the comments will ask, why not stream sequences continuously like table data? Because it would be prohibitively expensive. A table with 1 million inserts per day advances the sequence 1 million times. Streaming each one doubles WAL volume for a counter the subscriber does not need until failover. Sequences are metadata about the next value. Past values live in the table rows, which stream continuously. Only the what comes next pointer needs syncing, and only at switchover time. When should you refresh sequences? Before planned failover. Before promoting a subscriber. After a major version upgrade. After large bulk inserts. For hot standbys, you can schedule it every 60 seconds with PG_cron. How do you check if your sequences are synced? Query PG_subscription_L. Join to PG_ filter by relkind equals S for sequences, and look at substate. I for init needs sync. R for ready, synced. After refresh sequences, all 3 sequences show ready. Monitoring tip: alert if any sequences are stuck in init for more than a few seconds. A stuck sequence sync worker means your failover is not safe. How fast is this? Deepesh tested on the development branch in November 2025. He created 10,000 sequences, advanced each one randomly, then ran refresh sequences on the subscriber. Total time, roughly 770 milliseconds. That is 0.077 milliseconds per sequence. Most production databases have 50 to 500 sequences. At this speed, sync time is dominated by network latency, not sequence count. Performance is not a concern for any realistic workload. Caveat: this was tested on a development branch on localhost. Production performance varies with network latency and server load. Always benchmark on your setup. Let me be honest about the limitations. No per-sequence publishing. You cannot publish individual sequences. It is all sequences or nothing. Granular selection with an accept clause is proposed for PG20. No DDL replication. Create sequence on the publisher does not replicate. You must create the sequence on both sides manually. No continuous streaming. Values only sync when you explicitly refresh. Between refreshes, values drift. You cannot add all sequences to an existing publication. You must drop and recreate, or create a second publication for sequences only. And watch for privilege issues: the subscribing user needs usage privilege on target sequences. Missing privileges cause silent sync failures. Stopwatch 1530 to 1630 The PG19 upgrade workflow. This is the slide you came for. The old upgrade workflow meant logical replication: wait for sync, stop writes, then manually copy every sequence with shell scripts and race-prone setval calls. In PostgreSQL 19 you create a publication for all tables and all sequences, create the subscription, wait for sync, refresh sequences once, and promote. 40 lines of shell becomes 2 lines of SQL. Serial, identity, and standalone sequences are all caught. No race conditions on failover. 5 patterns for production use. 1. Upgrade via logical replication. All tables, all sequences on the old primary. Subscription on the new version. Refresh sequences before cutover. Promote. 2. If you already have a table-only publication, create a separate sequence publication. For all sequences with its own subscription. 3. For hot standbys, schedule refresh sequences every 60 seconds with PG_cron. Maximum drift is 60 seconds of sequence values. 4. The pre-failover checklist. Refresh, check PG_subscription_L, stop writes, refresh again, promote. 5. The monitoring query. Count sequences stuck in init. Alert if greater than 0. Sequence sync is the headline, but PG19 has more logical replication improvements. Dynamic WAL level adjustment based on active replication slots, less WAL overhead when no subscribers are connected. Improved lag tracking for better monitoring. Google contributed enhanced conflict detection for active setups. And PG_create subscriber improvements that work better now that sequences are supported. The big picture, logical replication is maturing toward being the primary upgrade and migration path. DDL replication is the last major gap expected in PG 20 or 21. Let me recap. All sequences, 2 new words in create publication. Publishes serial, identity, and standalone sequences. Refresh sequences, new alter subscription command. Resyncs all sequence values on demand. Run it before failover. Performance, 10,000 sequences in 770 milliseconds. Not a concern. Remember, snapshot sync, not streaming. Refresh before failover. Always verify with PG_subscription_L. Cannot add to existing publications. If you manage PostgreSQL in production, this is the most operationally significant logical replication change since PG10 introduced the feature. 2 words. 7 years overdue. Finally here. That is the full walkthrough. 20 slides. If you want the demo sequel, the monitoring query, and the upgrade checklist, comment sequences on this video. I will put everything in the pinned comment. If this helped you, subscribe. I release practical PostgreSQL videos regularly. Allah Hafiz.